what defines a constraint in Sudoku Maker is, first of all, we have an input for it. An input is basically which cells do you apply the constraint to. And the constraint could be global or local. And let's actually start from the local one and see how to build it. So we can uncheck the global constraints. We can see here a nice description that in the code the groups can be accessed via input groups. So what is exactly the groups? Let's see. Now that we uncheck the global constraint and we save the changes, we see that a new thing, add group, appears here. So the way to add the group is to select one or more cells. So it's basically like for one instance of the constraint, for instance, one Kropki dot, one line, one cage, and so on. Which cells do you apply this constraint to? So I want to use a ratio line between these two cells, so I add an input group for these cells. Now I want to add one more and one more, and so on and so forth. So we can add any amount of input groups this way, and that's how we specify for which cells do we want to apply the custom constraint. Now, the small problem with that is that the moment you unselect the custom constraint, it all goes away. Like it's still in the memory, but you see no visual clues for which cell you applied it to. So there's no automation for that. So the only way to keep like visual track of which input groups you added is to just use any other cosmetic constraints. So we can add a cosmetic line and manually draw the lines here. I already did it in advance. Let's enable it back, and let's finish the last input group. Now that we have all the inputs, what can we do with them? Let's return to the make. So basically this text box contains a piece of code that we need to implement, and the purpose of this piece of code here is to analyze the input groups, like analyze what's the input of our constraints, and use the puzzle at constraint component API to add all constraints to the puzzle. So here we can uncomment the template, which does the thing that we usually will need to do. We go in over all our input groups. So groups, each group here is exactly what we entered here, and we can use puzzle at constraint component to add the component based on this input. For instance, we see here that the group object contains a cells property, which is basically just an array of cell IDs that we specified in the UI. And we add a new object for the component that we need to use. In this example, I'm trying to implement a ratio line, which basically means that for each pair of adjacent cells on the line, their ratio is 1 to 2. So one of them is twice the other. So in this case, we don't need to reinvent the wheel. We can look at the components that we already have here, maybe do the search, maybe something already does the ratio. Yeah, we have a ratio component. And here the documentation says which arguments it accepts and what it does. So the ratio of the values of cell 1 and cell 2, and it's these, must equal ratio of ratios, which is this argument. And it describes it in a TypeScript fashion, like argument name and argument type. So we need to specify the component name, and we need to specify one or more numbers for the ratios that we expect, and we need to give 2 cells to it. So let's go ahead and do it. We need a ratio component name. We will return to it a little bit later. We need the ratio of 2, cell 1, cell 2. And in case when we're using the standard components, we don't need to do anything else. That's basically it. Let's remove that. So actually that's not the case here, because input group will contain many cells for the big lines, and then we're taking only the first 2 of them. But let's see what we already have. So for instance, for the short lines, we can see that it's already doing some logic, like it excluded 5, 7, 9, because it cannot be 1 to 2 ratio with anything. Yeah, and I forgot to tell that's a puzzle with 0 to 8 as a digits. Yeah. And for instance, on this line, we see that it applied the logic only to the first 2 cells on the line. So let's go ahead and fix that. And basically what we have here, what the platform gives to us is 3 global objects that could contain different information and do different things. The first of them is input, that I already explained. The second one, globally available thing, is puzzle. So the puzzle object gives some information about the grid. For instance, we can know how big is the grid. We can know what's the puzzle width and height, and we could also know what's the minimum and maximum digit that the puzzle supports, and so on and so forth. If you're coding a constraint for yourself, you can just hard code everything. Like if you know that the puzzle is 1 to 9, just use 1 to 9. But if you want to share your constraint with other people, prepare that they can use the constraint in a 6x6 puzzle or on a puzzle that supports 0 and as a digit, so you will need to use the specs. And the third global object that is helpers. And we have many categories of helpers, like cell IDs is the helper for internal cells, corner IDs for the corners between the cells, like helpers to work with lines. Like in geometry, you will see like different relationships between the cells. Like if you have one cell and you want to know all cells nicely move away from it, or all orthogonally connected cells, and like things like that, you will find them in geometry. So you can use autocompletion to see what's inside. Yeah, let's return the helpers here, and here we are working with the lines. So let's see what it has for us available for the lines. Helpers, lines, get all pairs along lines. That's looks like exactly what we need to get. So we can use we can add ratios for each pair of digits along the line. Unfortunately, like you saw that we have autocompletion for the methods and properties of all objects, like for most of them. What we don't have autocompletion for is the arguments that methods and classes and class constructions expect. In this instance, I know that I need to specify an array of lines, and later I will explain how to know it for yourself, like which arguments it needs to. So this method for the line, it will return all pairs. So like each of the cells here basically has 2 cells on the line. So let's move it here. And now we have just cells, not group.cells. Let's check. Yeah, we see that it already applied the constraint to all pairs along the line. Somehow the built-in functionality doesn't know that 0, 0 will not work here, but that's okay for now. Let's check if it's enough. Yeah, that's enough for the brute force, but that's not really enough for the logical solver. There are several sources when you can understand what all these objects and methods contain and do and so on. So first of all, we have some inline documentation. So it says that the groups could be accessed from input groups. Okay, we know that we can do that. And we have documentation for all built-in components. That's cool. The second source for knowledge is the template code that you see. So Sarksamic, the author of Sudoku Maker, did a very good job of writing the template code for everything. Basically, from the templates you can see the most popular use cases and the most used things. So, for instance, when we just added the constraint, we saw that it has a template code for adding some constraint just for each group of cells. And that's usually what you do. And from the example code, we know that there's a puzzle add constraint component that receives some component object. And we know that there's an input group, and that each input group contains a cells property, and so on and so forth. So many things and many examples of what you can do. You just get from the template code, like looking what it does, and probably you will need to do quite the same. The third way of understanding what happens here is, of course, the autocompletion. If I type puzzle, I know what's inside of it. I know that it contains these methods. So I know that inside of puzzle we have spec, and we have digit count here, and max digit and min digit, and so on and so forth. But what if it's still not enough to understand what's going on here? First of all, you can just ask in the Sudoku Maker thread in Skunkworks, and people will help you, but you can also do it yourself. So, for instance, we have a group here, and looks like we don't have autocompletion for it. So how could you know what's inside? Well, it's just a piece of JavaScript. So any methods for debugging the code that you use for JavaScript, you can apply them here. For instance, you can just add a console log and see what's inside. Let's see. Let's change something. Okay, so it looks like it has some proxy object, and these proxies you can basically disregard this. It's just regular kind of object. So looks we have array of cells and a value inside. So now we know which properties had and what is the format of these properties. Also, if you really want to look inside of something, you can add a debugger statement. It's a bit small here. Let's expand it a little bit. Yeah, so we just added a breakpoint, and now we should be able to add a watch for the variable that we have here. Yeah, exactly the same. Yeah, now I probably need to refresh the page in order to get away from that. Oh, or just close that, yeah. Oh, it actually didn't save, and that's a good thing. And another thing that we can do is if we want to explore what some object has inside, is to make it available in a global scope. And what I mean is to do something like that, like just make something a property of window, and you will see it in the console. Let's make it small again. And I probably didn't save it, didn't I? Yeah, I didn't. Just one thing to know when you do that is that the window object is not always available, so you usually need to check that it's actually here before doing that. Let's save, and now here we go. Here is the puzzle. Here are the helpers, and you could do anything with it. And when I don't know what some method, helper method, does here, and which arguments it accepts, let's go here. So, for instance, we have this get all pairs along the line. How do we know what it expects from us? We just don't. So let's see what's inside. And of course, the easier way is to just to ask in the topic. But if you want to do everything yourself, then you could just type it in and navigate to the code, which is of course obfuscated, but usually it's simple enough to understand what it's doing. So we see that it's a generator function that accepts some collection, and inside of this collection looks like we have the array of cells. So it we can know from the code here that it accepts an array of lines, like multiple lines. Each line is the array of cells. And that's kind of complicated example. Usually it's much simpler than that. When you use the console to debug things, and you use the solve step-by-step button or find all solutions and valid candidates button, then the console might be just flooded by the logs. So while it could be handy sometimes to add the logs here, let's check if I still have some. No, I don't. Like somewhere in the update function or the validate function, just remember that it's been called every time on each step, and better don't add console logs inside of these functions unless you're going to debug step by step, because it not only floods the console, it also slows down the process. Like it takes time to write to the console. It's actually very easy given the scrolling and UI updates and everything. So the solution finder might be suddenly very slow if there's some output in there.